Day 705 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. In a day, we have question number 3653, XOR after range multiplication queries 1. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums of length n and a 2D integer array queries of size q, where queries of I is equal to li, ri, ki, and vi. For each query, you must apply the following operations in order. First, set idx equal to li. While idx is less than or equal to r of I, update nums of idx equal to nums of idx times vi mod 10 to the 9th power plus 7, set idx plus equals plus equals ki, and then return the bitwise XOR of all elements in nums after processing all queries. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 1, 1, 1, and queries also equals an array or a 2D array of integers with only one array being 0, 2, 1, and 4. The output is 4. So let's go ahead and see how they got this output from this input, right? So we only have one query. We have a single query, that's this right here. So it says a single query 0214 multiplies every element from 0 through index 2 by 4. So let's break that down one step further, right? So first, let's go through the operation. So first we need to set idx equal to L of I. So in this case, L of I is equal to 0. Boom. So we're going to set IDX equal to 0. So we have index 0. Boom. Then we're going to update nums of IDX by multiplying it by V of I. So, or while IDX is less than R of I. So in this case, R of I is 2. So we have all of these to work with. We have 0, 1, and 2, every element that we're working with, right? This is our range. Sorry, y'all, I was moving too fast. So LDX, we're going to set at LDX, right? So, we're going to set at L of I. So L of I is 0, so we're going to start right here at 0, right? Then, while IDX is less than or equal to R of I, so in this case, R of I is equal to 2. So our range is index 0 to index 2. So this is our range right here. Boom. Then we're going to update nums of IDX equal to nums of IDX times V1. So in this case, V1, as you can see right here, or excuse me, not V1, VI right here is 4, right? So that means we're going to update each of these by 4. So we're going to update this by 4, this by 4, or multiply this by 4, multiply this by 4, and multiply this by 4. After we multiply everything by 4, the array changes to this. Boom. So now we have 4, 4, and 4. Because we just, once again, we're multiplying each index by V of I. V of I is the last element in the query, right? So that's where the 4 comes from. V of I. Boom. So, and then we increment by K of I, and in this case, K of I is 1. So first we do this one, then we set the index to this one, then we set the index to this one. So just my bad, to make it more clear, we start here, boom. We have our range. We start at 0, then we run this operation, boom. After we run this operation, we move on to the next index by incrementing by K of I, which is 1. So after this, we just move up 1 to the next index. Boom. Then we complete these operations again. And once we get to the last one, once again, we set KDX or IDX to K of I, and that's how we move through this array. So that's how we got these 4s. But once we get the 4s, we need to bitwise XOR all of the elements and nums after processing the query. So this is all of the elements and nums after processing the queries. Now we need to bitwise them. So let me show you how the bitwise work. We know it's going to equal 4, but the rule for bitwise is, let's say, same bits equals 0, different bits equal 1. Boom. So let's go through this XOR, right? So for 4 is O, the bitwise representation of 4 is 0100. Boom. So that equals 4. So now we are going to just bitwise them. Boom. So we have 3 4s. So we bitwise the first two, same bit 0, different bits 1. So 0, 0, 0, 0. Because as you can see, when we're comparing, I'll just put these here. Boom. After comparison, these are the same, these are the same, these are the same, these are the same. But that's just for these 4s. Now we got to do this third 4. So once again, we go 0, 1, 0, 0. Boom. After we do that, and we compare these, sorry y'all. What the heck? After we compare these right here, we get same bit 0, different bit 1, same bit 0, 0. So in the end, we still end up with 4. So that's how we got this output of 4 after we did the XOR. Boom. So just in case that didn't make sense, y'all, let's take a look at example 2. Example 2, same principles apply, but we get a little bit more queries. So that's where it could get a little bit more tricky. I'm going to leave the bitwise OR rules up there. So in example 2, we have our input nums equals an array of integers 2, 3, 1, 5, and 4. Queries equals a 2D array of integers. First query is 1, 4, 2, 3. Second query is 0, 2, 1, 2. Boom, the output is 31. Let's see how they got this output of 31 from this input, right? So the first query is this. So since this is a little bit long, I'm going to just copy and paste both of these over here so y'all can see what's going on. So then we'll come over here, we'll say Q1, we'll set this equal to this, boom. And then we'll come over here and we'll say Q2. So this is query 1, this is query 2, and then query 2 is this right here, boom. So we're going to run both of these queries, and I'm going to explain to you how they work just in case you didn't understand the first time. So the first query is this right here. So boom. First query, that means we are going to start, we're going to set IDX to L of 1. So once again, L of 1 is equal to this 1 in the query. So we're going to set our IDX, to this 3. So we're going to start right here at this 3. So let me copy and paste this as well so y'all can see better. Boom. So right now, first operation, we set IDX to L1. So Li is 1. So we set that to index 1, which is this 3. Boom. Now, while IDX is less than or equal to R of I. So this time R of I, in this case, will be 4. So we're going from index 1 to 1, 2, 3, 4 to index 4. This is our range right here, right? 1 through 4. This is the range they give us. This is the range that we're working with, right? Boom. Then, so now we're going to take nums of IDX and multiply it by V of I. So right now, nums of IDX is equal to 3. Boom. So we're going to take 3 and multiply it by V of I, and in this case, V of I is 3. So we're going to take this 3, multiply it by this 3, and this 3 is going to become 9. Boom. Then we need to increment IDX by K of I. So K of I is right here. In this case, K of I is 2. So we're going to increment IDX by 2. So we're going to go 1, 2. Boom. Now we're right here on this 5. Then, now that we're on this 5, we're going to run the operation again because this is still in our range. Remember, our range was from here to here. So after incrementing, we're still in the range, right? So now we're going to do the same thing. This is the new IDX. We're going to multiply this by V of I, which is this 3. So after that multiplication, boom, this becomes 15. Boom. Then that's it for the first query. It says, boom. After that, we're out of range, right? Because if we increment from by 2 again, we'll be out of range. So we can stop right there for the first query. Boom. So let's just get rid of this first query. Now we are going to perform this second query. We can actually get rid of this too, because we're going to perform the second query on this array right here. Boom. So let's come right here. Now for this array, let's go through it again. So first we're going to set IDX to L of I. L of I is 0. Boom. So we're going to start right here at index 0. Then R of I, so y IDX is less than or equal to R of I. In this case, R of I is equal to 2. So we're working with 0, 1, and 2. Boom. Or, yeah. Hold on, y'all. Hold on. So, hold on. Because, okay, yeah, that's right. Boom. So this is our range right here. Then, now that we have our range, we are going to multiply. We're still here though. That's just the range. We're still starting here. So we're going to multiply this IDX by V of I, which in this case is 2. So we're going to multiply this by 2. Boom. This becomes 4. Boom. Then after doing that, we're going to increment IDX plus equals K of I. In this case, K of I is equal to 1. So we're just going to move down the line. Boom. We're going to increment IDX by 1. Now we're at index 1. Index 1, once we do this, we're going to repeat the same operation. So now we do index 1 times V of I. V of I is still 2. 9 times 2, that becomes 18. Boom. Then we keep on moving down. But remember, this is our range. We stop right here at this 1 at index 2. But we do the same thing. We multiply this 1 by V of I, which is 2. Boom. So this becomes a 2. And then now we're out of range, right? We could increment IDX by 1 again, but we're out of range because remember, this is our range. We already changed these 3 elements, so we could stop here. But we're not done yet because, well, first let's make sure that's the right, that's right. Let's make sure, come down here. 4, 18, 2, 15, 4. Boom. Yep, that's right. But we still need to XOR all of the elements 4, 18, 2, 15, and 4. So let's go ahead and do that. So let me see. So 4 would be 0, 1, 0, 0. 18 would be 0, or excuse me, it would be 1, 0, 0, 1, 0. Boom. So that's, let me make sure that's 18. 2 would be 0, 0, 1, 0, 0. Boom. Oh, excuse me, 1, 0. Sorry, y'all. Then 15 would be 1, 1, 1, 1. And then 4 again would be 0, 1, 0, 0. Now we got to add a leading 0 to all of, not this one, but just so, because of this 18 right here, we need to add a leading 0 to the rest of them. Boom. Now we're going to compare these with the bit XOR like we did up here, right? So first we're going to compare these two. Boom. So let's just, so we can clean this up. After we compare these two, once again, same bit 0, different bits is 1. So same bits, oh, let's come over. Same bit, 0, different bits. So this would be a 1 because these are different bits. These are the same. 0, 0 is 0. So those are same. Excuse me. These are different. 0, 0 is the same. So we put a 0. Then 1 and 0 right here. Those are different. So we put a 1. Then 0, 1 are different. We put a 1. 0, 0 are the same. So we put a 0. Boom. Now we have to compare this. So let's bring this up while we do this one. Boom. So after this, let's see. Let's see. Okay, so 1, 0, different bits is equal to 1. So that'd be 1, 0, 0, same bit, 0, 1, 0, different. Boom. 1, 1, the same. So that would be a 0, and 0, 0, the same. That would be a 0 as well. Boom. Let me just make sure, double check my math real quick. Boom, boom. same bit 0, different bits 1, boom. Now we have to, let's move this up. Now we gotta compare this, boom. So let's move this up, we right here now. After we compare these, 1, 0, different bits equals 1, 0, 1, different bits equals 1, 1, 1, same bit equals 0, 0, 1, different bits equal 1, 0, 1, different bits equals 1. Boom. Now finally, last but not least, we need to do the last one. So this should be, different bits is 1. So hold on. Let me just do this. Boom. Now let's compare. So different bits, once again, is 1. Different bits is 1. Different bits is 1. Different bits is 1. Same bit, 0. Boom. And then, so 30, that should be 31. 1, 1, 1, 0. So this should equal 31. Boom. And that is how we got our output of 31, y'all. So I hope that makes sense to y'all. And just in case it didn't, or I hope it did, it makes sense to y'all. But now that we understand the question, let's get into the fun part, the actual solution, y'all. The solution should hopefully help it make sense if it doesn't already. And if it does, we still got to do the solution. So let's get into it now. The first thing we need to do is we need to create a mutable copy of the input array since nums is immutable. So we're just going to come right here and declare a variable called nums, and we're going to set that equal to nums. Boom. Then we need to iterate through each query. So we'll say, come underneath this, we'll say for query in, well, I guess this should have a Y. For query and queries, we're going to open up the brackets. Boom. And for each query is going to be structured as, so well, let's go through it. We're going to say then we're going to loop through the specified range using the given step stride, which will allow jumping by queries of 2 instead of queries of 1. So we're going to say for index in stride, open up the brackets, from colon query square bracket 0. So that's going to be the start index. Then we'll say comma 2 colon query square bracket 1, come outside of that, plus 1. That's going to be the end index. Then we'll say comma. Then we'll say by colon query square bracket 2, and that's going to be how many steps we increment. Boom. Then we're going to come right here outside of this, open up the brackets, and we're going to multiply the current element by the given multiplier and take the modulo to prevent overflow and keep numbers bounded. So we're going to say nums square bracket index. Come outside of that, we're going to set that equal to nums square bracket index times, index, come outside the square bracket times query square bracket 3 square, and that's the multipliers. Query of 3 is the multiplier. Then we're going to mod that by, that should be mod. We're going to mod that by 10 to the 9th power plus 7 by saying 10, 0, 0, 0. Or let me see, it should be 1. Then how many zeros we need? 1, 2, 3, 4, 5, 6, 7, 8 zeros, and then 7 on the 9th. Boom. Hold on, let me see. That's why I do the underscores. The underscores make it easier. Boom. So with the underscores, it should look something like this. Boom. Then after processing all queries, we're going to compute the XOR of all elements, and reduce is going to start from 0 and apply the XOR across the array. So we could come right here, and all we have to do is say return nums dot reduce open up the parentheses, 0, comma, and put the XOR operator like that. Boom, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 73 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, make sure you get one more look at the code. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.